Welcome to a lesson with Dr. Powell. Let's take a look at an example of computing curvature. Okay, so let's just take this simple curve here. Suppose we have something like cosine of t, and let's use this notation, cosine of t, sine t, and then maybe just t. Okay, let's compute the curvature of this. This is a helix and it winds up and gets higher because of this component right here. So let's think about how to compute the curvature of this using the idea that we talked about, at least the definition that we gave in the last video. So to do that, we would first find, let's first find v. So v is just the derivative of this, which is negative sine t, it's cosine t, and then it's 1. All right, now we can find the length of this. Okay, so that would be the square root of that squared plus 1. Now, sine squared plus cosine squared is going to be 1 plus 1 squared is going to be just 2. So we're looking at a constant. That's kind of handy. In this particular case, we actually get a constant for this, so this doesn't really depend on t, so that'll be very nice in our calculations in this particular example. So now we want to be able to find the unit tangent vector, but that should be easy because you're just taking this vector and dividing it by that. So the unit tangent by its length, unit tangent vector is simply just 1 over square root of 2 times minus sine t, cosine t, and 1. Okay. Next, we need to be able to find the derivative of t. So dt dt, what's that? Okay, thinking of that, we'll just take that and take its derivative. So with respect to t, so you end up getting negative cosine t, negative sine t, and 0. Okay, so that's dt dt. And remember, in our calculation, we take dt dt and then we divide it by this length right here, which is the length of ds dt, or just this right here, square root of 2. So we basically just take the length of this guy and divide it by square root of 2, which in this particular case is just like, since this is a constant, we may as well just divide it by it right now. So if we divide this vector by square root of 2, it's like popping it in the denominator here, which just makes this 1 over square root of 2 times square root of 2, which is like 1/2. So really we're looking at the length of the vector 1/2 times negative cosine t, negative sine t, 0. So just the length of this vector. Now, if you think about this squared plus 0 squared, and that's just going to be 1. So the square root of it is just 1. So really, we're looking at 1/2. So in this particular case, this helix curve, it has a curvature of 1/2. Thanks for watching.